Hello friends, we Aditya Jain and Shreyansh are going to explain construction of a LALR table and construction of a DFA for a given regular expression with some questions. We would like to thank VIT University Vellore and Professor Kannadasan R for giving us an opportunity to work on this video. In this question we are going to explain construction of LALR Parsing Table. First L gives L equal to R, S gives R, L gives star R, L gives ID, R gives L. So the unambiguous LR1 grammar is given. So we will augment S dash gives S, and then we will construct the LR1 items. So the grammar becomes S dash gives S gives L equal to R, S gives R, L gives star R, L gives ID, R gives L. So item 0 contains S dash gives dot S comma dollar, S gives dot L equal to R comma dollar, S gives dot R, L gives dot star R comma equal to hash doll equal to hyphen dollar, L gives dot ID comma equal to hyphen dollar, L gives dot L comma dollar. So I0 comma S, which contains S only, will go to I1. I0 comma L, which contains S gives dot L equal to R, will go to I2. I0 comma R will go to I3. I0 comma star equals to I4. I0 comma ID equal to I5. And again I0 comma L, as stated above, will go to I2. Now item 1 will contain S dash gives S dot comma dollar. I2 will contain S gives L equal to L dot equal to R comma dollar. R will give L dot comma dollar. So I2 which contains S gives L equal to L dot equal to R comma dollar, that is I0 comma equal to will will become equal to I6. Now I3 contains S gives R dot comma dollar. I4 will contain L gives star dot R comma equal to hyphen dollar. R will give dot L will give dot star R, L will give dot ID comma equal to hyphen dollar. So I4 comma R will become equal to I7. I4 comma L will obviously become equal to I8. I4 comma star will become equal to I4. I4 comma ID will become equal to I5. So item 5 will contain L equal to L gives ID dot comma equal hyphen dollar. I6 will contain S gives L equal to dot R comma dollar. R gives dot L comma dollar. L gives dot star R comma dollar. L gives dot ID comma ID comma dollar. So I6 of R will become equal to I9. I6 of L will become equal to I10. I6 of star will become equal to I11, and I6 of ID will similarly become equal to I12. Now item 7 will contain L gives star R dot comma equal to hyphen dollar. Item 8 will contain R gives L dot comma equal to hyphen dollar. I9 will contain S gives L equal to R dot comma dollar. I10 gives R gives L dot comma dollar. I11 gives L gives star dot R comma dollar. R gives dot L comma dollar. L gives dot star R comma dollar. L gives dot ID comma dollar. So as stated above, I11 comma R will become equal to I13. Um, I11 comma L will become equal to I10. I11 comma star will become equal to I11. I11 comma ID will become equal to I12. So I12 will contain L gives ID dot comma dollar. I13 will contain L gives star R dot comma dollar. So now we will explain construction of LALR1 parsing table. We have already constructed sets of LR1 items. Now we will combine LR1 sets with sets of items that share the same first part. So in I4 and I11, in both we have the first part is same, that is L gives star dot R gives dot L gives dot star R, L gives dot ID. So first part is same, so we will use a shorthand for two items in the same set. Since the grammar is unambiguous, so we'll augment s dash with s. So s dash will give s gives L equal to R, s gives R, L gives dot star R, L gives ID, R gives L. Now we will construct LALR1 items. So LALR1 items are as follows. So item 0 will contain s dash gives dot s comma dollar, s gives dot L equal to R comma dollar, s gives dot R, L gives dot star R comma equal to hash equal to hyphen dollar, L gives dot ID comma equal to hyphen dollar, L R gives dot L comma dollar. So I0 comma s will become equal to I1, I0 of L will become equal to I2, I0 of R will become equal to I3, I0 of star will become equal to I4, I0 of ID will become equal to I5, and I0 of L will become equal to I2. So I1 will contain s dash gives s dot comma dollar, I2 will contain s gives L dot equal to R comma dollar, R gives L dot comma dollar. So I0 of equal to will become equal to I6. Similarly, I3 gives in I3 will contain s gives R dot comma dollar, I4 will contain L gives star dot R comma equal to hyphen dollar, R gives dot L comma equal to hyphen dollar, R gives dot star L dot star R comma equal to hyphen dollar, L gives dot ID comma equal to hyphen dollar. So I4 of R will go to I7, I4 of L will become equal to I9, I4 of star will become equal to I4, and I4 of ID will become equal to I5. So I5 will contain L gives ID dot comma equal to hyphen dollar, I6 item 6 will contain s gives L equal to dollar L equal to dot R comma dollar, R gives dot L comma dollar, L gives dot star R comma dollar, L gives dot ID comma dollar. So I6 of R will become equal to I8, I6 of L will become equal to I9, I6 of star will become equal to I4, I6 of ID will become equal to I5. In the same way, L gives in I7, L gives dot star, L gives R star R dot comma equal to hyphen dollar, I8 gives S gives L equal to R dot comma dollar. Um, Item 9 will contain R gives L dot comma equal to hyphen dollar. So equal to hyphen dollar is a shorthand for two items, that is R gives L dot comma equal to and R gives L dot comma dollar. So now we can finally construct our LALR1 parsing table. So in this we have a grammar of s dash tends to s. So that will be a state 1, that is s1. S gives L equal to R will be s2. S gives R will be s3. L gives star R will be s4. L gives ID will be s5 and R gives L will be s6. There are 9 items from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So item 0 of ID will be S5 and item 0 of star will be S4. Similarly, item 2 of equal to will be I2 comma equal to will be S6 and I2 comma dollar will be R6. uh, Item 3 of dollar will be R3. Item 4 of ID will be S5 and star will be S4. Similarly, item 5 of equal to will be R5 and item 5 of dollar will be R5. Item 6 of ID will be S5 and I6 of star will be S4. Similarly, item 7 of equal to will be R4 and item 7 of dollar will be equal to R4. Um, Similarly, I8 of dollar will be R2, I9 of equal to is R6 and I9 of dollar is also equal to I6. Similarly, S of 0 is 1, L of 0 is I2, R of 0 is I3. Similarly, I4 of L is I9 and I5 of R is I7. Also, I6 of L is I9 and I6 of R is I8. So we have successfully generated an LALR parsing table.
Hello friends, today we will be constructing a DFA for the given regular expression, that is a plus b star ABB plus a positive closure b. In order to construct the DFA for the given expression, we will first be constructing an NFA for the same. So to reach the final stages, we need to have either ABB or a positive closure b in the last of the expression to get it accepted. So we proceed with the starting state as 1, and we will stay at the state 1 for n number of times a and b occurs. And when this is done, we will either proceed towards 2 1 2 3 4 if we get a b b, or we'll go through the path 1 5 6 if we get a as n number of times and the b in the last to is the final states. The two final states will be 4 and 6. So we'll check with the expression. Expression 1 is a b b. So when we process the first a, we stay at state 1, second a also stays at state 1, third a also stays at state 1. When we get the fourth a, we proceed and we get to the state number 2, and when we get the first b, then we go to the state 3, and when we get the second b, we go to the state 4, that is which is the final state. And now we will take the example number 2, in which we will stay at the first state at now first a, and then we will proceed to the fifth state on the second a, and we will stay at the state fifth till all the number of a's are finished, and then in the last when we have the single b, we proceed to the state 6, and which is the final state. Hence both of the examples are accepted by the given NFA. Now to convert the constructed NFA into DFA, we need to make a table for the given transitions. So we have to see for the from the first state where all can we reach on giving the input symbol as a. So we can reach to the states 1, back, 2 and 5. So we put 1, 2, 5 in the a column of 1, and if we give b to the first state, we stay at b for the first state itself, and from 1 to 5 we make another state, and we have to see where all can we go with the help of a. So with the help of a, we stay here only, that is we stay in 1, 2 and 5 there itself if we give a, and if we give b, we can reach the states 1, 3 and 6 from the states 1 to 5. And from the state 1, 3, 6, if we give a, we go back to the states 1, 2, 5, and if we give b to the state 1, 3, 6, we go to 1, 4, and 4 is our one of the final states. And from 1, 4, if we give a, we come again back to 1, 2, 5, and if we give b again to the state 1, 4, we reach back to our starting states, which is 1. So we make new states as 1, 2, 5 and 1, 3, 6 and 1, 4 according to our table constructed. And now In the last, we just need to map the given table or the constructed table which we have done right now into a DFA, and our solution is complete. So the solution which we get after constructing the DFA for the table computed is given as follows. Thank you for giving your time and viewing our solutions to the given problems.